cross products. Cross product of two vectors. Suppose this is a vector P and this is the other vector Q, originating from the same point. Suppose this point is O and the angle between them is phi. Then cross product of P and Q is defined as P cross Q is equal to magnitude of P times the magnitude of Q times sine of the angle between them times a unit vector which is perpendicular to both P and Q. Okay. Now, if this unit vector is perpendicular to both P and Q, there are two possibilities. One, the vector is into the plane of the board. The other vector is out of the plane of the board. The symbol goes like this. Suppose an arrow, if you take an arrow and you look from this side, what shall you see? The arrow is coming toward you, right? So if the vector is coming out of the board, that means you are looking into the board and the vector is coming out of the board, the symbol will be like this. Again, if you look from this side, you will see the feather from this side. Okay. So the feather, how shall you see? It's just a cross. And so you just see the feather. So it is going away from the board, it's away from you. So it's going into the board. So the symbol is like this. So this is into and this is out. Now this n cap is the unit vector which is either into the board or out of the board. That is the only two possibilities if the resultant vector is perpendicular to both P and Q. Fine. Now, which shall I take, into or out? The rule is rotate the first vector. First vector, which is the first vector? This is the first vector. And which is the second vector? This is the second vector. So rotate the first vector through the shorter angle. So as to coincide with the second vector. That means you have to rotate P to meet Q. Q is the second vector through the shorter angle this way. You must rotate P to meet Q this way, not this way. Not this way. This is the bigger angle, not this way. This way you must go. Okay. So rotate the first vector through the shorter angle so as to meet the second vector. The direction of the tip of a right-handed screw rotated in that direction gives the direction of the vector. Fine. The direction of the tip of a right-handed screw rotated in that direction gives the direction of the vector. That means you have to rotate the screw like this. Rotate the right-handed screw. I think you have seen right-handed screws. All normal screws are right-handed screws, right? The opening of the tap. If you open the tap, if you rotate the tap in an anti-clockwise fashion, the tap comes up. That's why the water falls. There are very few screws which are left-handed, and few screws are intentionally made left-handed. I show you one. This one. This is whiteboard marker Camlin. This screw is left-handed. If you rotate it anti-clockwise, it will not open. You have to rotate it clockwise. See, I am rotating it clockwise and it's opening up. Why, you know? Because while teaching, we may have a habit of opening this absent-mindedly. Suppose we are thinking something and we just rotate it and it comes up, right? We have a habit of opening it in a anti-clockwise fashion, but even if we rotate it in an anti-clockwise fashion, this will not open. This will only tighten, right? So it is intentionally made left-handed. This is a left-handed screw, but I think this one is right-handed. So if you rotate it in an anti-clockwise fashion, no, this is also left-handed. These are intentionally made left-handed because this is art line, intentionally made left-handed, because absent-mindedly if you rotate it, it will not spill over. The ink is full, it will not spill over. So this is the reason. So right-handed screws, all normal screws are right-handed screws. If you open a tap, so tap comes up, so you open it anti-clockwise, tap comes up. So the motion of the tap is up. Motion of the tap is up, right? So here in this case, end cap will be, here you are rotating in a clockwise fashion. See, P2Q is clockwise. So if this clockwise, so end cap will be, into the plane of the board, right? So this vector, this is a vector product. The resultant of P cross Q is a vector. This is a scalar. This part is a scalar. Scalar times a unit vector. Unit vector doesn't have any dimension. All the dimension is carried by this magnitude part, P, Q, sin theta. And see, if this is length and this is length, this is basically the area. This P cross Q is actually the area of a parallelogram made by PQ, and you translate this Q and translate this P, you will get the area of the parallelogram. I will come to that. But first, just understand the direction. This is very important. I am repeating the statement. Rotate the first vector through the shorter angle so as to coincide with the second vector. This is the first vector, this is the second vector. You rotate it, this will meet, the first vector will meet the second vector. The direction of the tip of a right-handed screw, you tighten a right-handed screw like this, this will go in. So the direction of the tip means the tip of a right-handed screw rotated in that direction gives the direction of the vector. Fine. So this gives you a direction. I'll show you another figure. Let me draw another figure, then we'll be able to understand how the direction works. So let's erase this. You understand this P and Q is on the plane of the board, but I want to draw a 3D figure so that P and Q comes out of the board. So suppose I drawing my right hand. It is a little folded right hand or anybody's right hand. I am not an artist, so please forgive me for that, but I hope you will be able to understand. And this is the thumb finger. So this is your right hand. It is folded. Okay, this is your right hand and it is folded. This finger, these 4 fingers points the direction of rotation. Now if this vector is P and this vector is Q, both coming out of this plane of the board, so you are rotating from P to Q, right? You are rotating it from P to Q. So this is, you are rotating like this, and this thumb will give the resultant vector P cross Q. I think you understand. You should rotate. This is the shorter angle phi. This is the shorter angle phi. This is the shorter angle phi. So the n cap, the unit vector n cap, will point perpendicular to this plane which contains P and Q, and it will point perpendicularly up. So here P, Q, sine phi, n cap. Okay, I think you got the direction. This is very important. If you rotate it from P to Q through the shorter angle, this thumb will give you the direction of the resultant vector. This is cross product. See, the resultant is a vector. The resultant is a vector. So this is also called a vector product. This cross product is also called a vector product. There is another name for this cross product. You see, the resultant vector is not in the plane of P and Q. The resultant vector is not in the plane of P and Q. It comes out. So this is also called outer product. This is also called outer product. Fine. I shall show you in the next video how we calculate this P's cross product and get the area of a parallelogram made by P and Q. Thank you.